Hello friends, today let us see the details of static relays which are used for the protection purpose in power system. Now the term static relay generally refers to a relay where active semiconductor devices such as diodes, transistors, ICs, etc. are employed for processing the electrical input signal in order to obtain the desired relay characteristic. The operation of the final contact may be either initiated by a solid-state device or an electromechanical device. So, before seeing the different types of static relays used for protection in power system, let us elaborate the advantages of static relays over electromagnetic relays. Now, the rapid changeover of technology from electromagnetic relays to static relays can be attributed to several advantages the latter process possesses. The major ones of these are as follows. First one is reduced burden. Now, static relays pose a reduced burden on protective current transformers and protective potential transformers as compared to electromagnetic relays because of lower volt ampere requirements of the static circuits. The advantages of reduced burden are battery accuracy of better accuracies of CTs and PTs. Difficulties faced due to CT saturation are overcome in this case. For the same current, the voltage required is reduced and hence the CT is operated in the lower part of linear characteristic. That is very much important. And CTs and PTs of lower volt-ampere rating are required, which results in the reduction of size and cost of CTs and PTs. So static relays offered reduced burden on the of the circuit. Now second advantage is no moving parts. Now solid state devices have no moving elements. Hence, in static relays, there are no problems of contact bounce, arcing, contact erosion, dry contact, spring restraint, etc., which can be observed in electromechanical relay. The static relays have operational advantage like high torque, absence of friction, etc. Now, next advantage is fast response. Now, very small operating time of the order of one cycle or even less can be achieved with static relays, and that is not possible in the electromechanical relays because more time is required for the operation of mechanism of those electromechanical relays. Next one is precise characteristic. The relaying characteristics would be controlled more precisely. Then next one is sensitivity. The case of providing amplification enables greater sensitivity to be achieved. So smallest change in the EC quantities in this case can be sensed by using the static relays. So the protection system will be very sensitive for the any abnormal condition in the power system. The next advantage is miniaturization. As the contact and small sized ICs are available, the size of static relay gets reduced. This saves the panel space of the system. Next one is robustness. High resistance to vibration and shocks as there are no moving parts. This is especially true in relays employing ICs, and generally ICs, that is integrated circuits, are used to construct the static relays. Then next one is less maintenance. With the absence of bearing friction and contact trouble, maintenance required is greatly reduced because there are no moving parts in the relay. Next one is flexibility. A variety of functions like sensing of negative phase sequence component of current or voltage, filtering, harmonics, differentiation, integration, etc. can be performed with greater flexibility by static circuits, and hence these relays can match the requirements of protection more closely. Next advantage is low resetting time. Resetting time can be reduced using static circuitry, where fast automatic reclosing of circuit breakers is involved. The resetting time of a relay may be a critical parameter for obtaining selectivity. Next one is low overshoot. As the over travel time is practically negligible in static relays because of absence of moving parts, discrimination time between successive relays can be reduced. Next one is low transient overreach. As the input signal can be easily differentiated by static circuits, the transient overreach of static instantaneous overcurrent relays is quite low. And one more advantage is there, that is high drop-off to pickup ratio, and which is also very important in case of the protective equipment in protection system. Now with these advantages, there are some limitations for the static relays. Some of them are mentioned here. First one is vulnerability to voltage transients. Now static relays are prone to voltage spikes. Such voltage transients can occur due to operation of breaker in the primary circuit of CTs and PTs, or breaking of control circuit, or atmospheric disturbances. Such voltage spikes can easily override the signal and cause serious malfunctions of the static relay, or can even damage the semiconductor components. Good filtering of the auxiliary supply, surge suppression, and shielding are the important requirements of the static relays to avoid these problems of voltage transients. Next limitation is variation of characteristic with temperature and age. The characteristics of semiconductors are affected due to variations in the surrounding temperature. Silicon transistors are much less prone to temperature effects than germanium transistors. Temperature effects can also be minimized by appropriate use of thermistors or appropriate compensating circuits. Aging can be minimized by pre-soaking for a number of hours at a relatively high temperature. Next limitation or disadvantage for static relays is overload capacity. The static relays have lower short-time overload capacity compared with electromagnetic relays. However, with improvement in semiconductor technology, there is significant rise in thermal overload capacity of static relays nowadays. And next one is reliability. Now, electromechanical relays have high reliability due to the fact that they have a smaller number of components and that each component possesses good reliability due to long experience gained in manufacturing practices. Static relays were less reliable initially for a few years, still the discrete components prove their reliability. Careful choice and quality control play a vital role in reliability of static relays. Due to the advent of integrated circuits which replaced discrete components, the reliability of static relays has considerably improved. Improved testing facilities and accelerated live tests also have increased the reliability of static relays, and hence they are replacing electromechanical relays in the field at a very fast pace. So these are the advantages and limitations of the static relays. Now some basic elements are used in the static relays. Now instead of building complicated circuit with discrete components like diodes, transistors, resistors, capacitors, etc., it is of great advantage to build them in an integrated form, that is in IC form. Now ICs employ either TTL, that is transistor to transistor logic, or MOS, that is metal oxide semiconductor logic. Complementary MOS logic is more in use. It has the advantage of small size and extremely low power consumption. However, they have to be handled with care as they are susceptible to damage due to static voltages. ICs of digital logic circuits, operational amplifiers, registers, counters, analog to digital to analog converters, and a multitude of other devices are available now commercially. So various elements are used for the construction of the static relays, and various basic circuits are used for the functioning of static relays such as level detectors, time delay circuit, output circuit, DC auxiliary supply and surge suppressor or surge absorbers, comparators including amplitude comparators and phase comparators, etc. So now in next part we will see the application of static relays or some different types of static relays and their connection diagrams or basic circuit diagrams. Okay, thank you.